My name is Leslie Marshall. I'm a corporate energy engineer, General Mills. And he already mentioned to you about our sustainability goals. We make food, and I hope you have some of our food at home waiting for you. But in addition to food, sustainability is very important to us. And we have a very strong stance on it because of climate change. We believe in climate change. We believe it's happening. We believe that it's happening because of human activity. Because it impacts our business, we believe we have a responsibility to address it. And we believe we can. So across our supply chain, as Rod mentioned, from 2010, we want to reduce our greenhouse gas emissions by 28%. So when we talk about across the entire supply chain, we mean from the moment that ingredient is harvested to getting to the manufacturing plants, to producing it, producing the final product, getting that product to our consumer, even to the point where our consumers eat the product and dispose of any kind of packaging material across our entire supply chain. That's the 28%. Now, the orange part of that column is the producing piece. That's where the manufacturing comes in. That's where my role is, getting our food processing plants to save energy. But it's also, it seems like a very small piece compared to that, but it's one of the most important pieces because it's one of the few categories where we'll actually save money, give money back to the business. So what that means is as we're looking for more sustainable, let's say, packaging materials, we realize that there's some instances where that's going to cost the company money. So the energy group that works on reducing energy at our plants is a very important part of our portfolio. We're also part of the Department of Energy's Better Buildings program, and we did meet our goal 4 years early. I was really excited about that. I didn't even know that was happening until I was informed by the Department of Energy. And my celebration was very quick-lived because I got a call from the Department of Energy, and they said, "Hey, Leslie, you met your goal." I was like, "Yeah, 4 years early. I could sit back and relax." And he said, "You need to start thinking about your next goal." And I was like, "What are you talking about? I have 4 years to think about what my next goal is. I can relax for a little bit." But we're very proud of that. 20% reduction, a little bit over 20%, 5% from 2018. So part of the Department of Energy, we like to participate in their in-plant training programs. And years ago, we did a compressed air in-plant training. And after we went through the process, we realized that there was a lot of opportunity. And we didn't really know how to approach it or how to roll it across the organization or how to get leadership's buy-in of it. So we got together and we made like some very general assessment of our state of compressed air through our North American plants and try to figure out what the opportunity was. And what we came up with was, for leaks, you'll see that in the blue column, that's our savings potential, and the green columns is what we think is going to be the capital investment to get after that problem. So air leaks, which I really do not like, you see that the savings potential, the capital investment to get after that savings potential is huge. You would definitely think that we're working on that, we're actively working on that. We'll talk about that more throughout the presentation, but unfortunately that's one of those things that's difficult to get after, as I'm sure you all know if you work in the compressed air industry. Inappropriate uses, a little bit more of a capital investment, but still a pretty good return on investment if we can fix that across our company. We really liked open air blowing. We like air knives, we like nozzles, we like those kinds of things that can be done in better ways. And then of course the rest of the other categories are typical categories in compressed air losses and opportunities. Still a very good return on investment if we were to focus on it. So basically what this was going to be, and when we added things up, just a broad generalization, was $6.2 million in savings in our North America plants. And we're actually doing this initiative globally, so there's more of an opportunity there. And then we also anticipate another $1.2 million in rebates and incentives. working with our utility companies, applying that money to capital to help us execute some of these projects. It would be very lucrative for us. Now, when we came up with this, go back to this $2 million in leaks, I was using an industry standard. They say that compressed air, worst case, 33%. Have you all heard that before, 33%? And I thought, okay, we're pretty bad. I can admit that, we're pretty bad. 33%, that $2 million is based off of. We're actually much worse than that. We're much worse. Some of our plants, 54% leak rate, non-production load. We take our readings off of a flow meter when we're down from production. 54% on average. I have a plant 75% leak rate, non-production load. I have a plant 87%. So that $2 million, even though we haven't recommunicated that number, is far bigger than that in compressed air leaks. So last year, I did talk about leaks because I was having some difficulty getting people to work, not just on compressed air, but really to prioritize all energy projects in the organization. And that's my job, is to get results. And it seems like, based upon some of our accomplishments, that 5% reduction in energy, that we're accomplishing that, but just not fast enough, really to my satisfaction. So I talked last year about some challenges that we were having, and I came up with this idea that I was going to get people to work on energy by not working on energy, because it just wasn't a priority for them. And what I meant by that was I was going to find what it was that was important to people, depending on what their role was in the company, and try to make an energy play off of that. So maintenance managers don't really see a utility bill. They don't know what that is. They probably have never even communicated with the utility company. They're not going to care about energy because that's not part of their metrics, right? Same thing with operations. Operations just wants to make product. And this goes not just for food, but for any industry. Probably operations managers are not going to be too concerned about energy. As far as saving money for the company, there are a lot of different ways they can do that besides that utility bill that really doesn't show up at the end of the year when they're sitting in front of their boss having their performance appraisal. But I gave some examples of ways that we could get after energy by finding something that's important to those other individuals that are using energy in your plant. So it's important that they work on it somehow. So I gave an example of dust collectors. We make flour, we handle flour. We have flour mills, we make cereal uses flour, we make dough products. A lot of flour, a lot of dust collectors. We have plants with 300 dust collectors in them. And as you know, dust collectors use a lot of compressed air, and when components on dust collectors fail, they can be using 300 to 1,000 CFM of compressed air very quickly. Even so, it's hard to get plants to have a sustainable maintenance program on their dust collectors, especially when they have so many. So instead of talking about the energy impact, the cost impact, we talk about the environmental impact and the human safety impact from having all that dust in the air. Nobody wants to breathe that dust, right? That's more important. Actually, human safety and environmental safety is more important to General Mills than anything else, besides just making good food, of course. I talked about steam leaks and steam trap maintenance. We have some pretty critical processes that rely on temperatures being at a certain level at very specific points in the process. And if you have steam leaks, you can't control your temperature. You can lose product. So instead of going out to operations and saying, hey, you've got the steam leaks, it's costing you a couple $1,000 a year, instead you approach them and you say, you have this steam leak, it's costing you tens of thousands, hundreds of thousands of dollars in product that you have to throw away because your Cheerio is not the most perfect Cheerio ever. That's important. And I talked about cost avoidance. So operations people, they do not know where compressed air comes from. The compressor is behind a closed door. They think the compressed air is free and they think it's unlimited. That's the truth. I used to be a process engineer supporting a production line, and I did not think about where compressed air came from. It came from a pipe. And all I had to do was tap into that pipe and I got all the compressed air I wanted. But at some point, you're going to run out of compressed air. And that capital that you need to add compressed air to the plant is better spent somewhere else, in a food processing plant. There are a lot of people vying for those capital dollars. And the reality is we want to spend capital dollars on things that the consumer is going to care about. We don't want to spend money on an air compressor. We don't put on the side of our Yoplait cup made with 100% strawberries and an oil-free VSD air compressor. That's not going to sell the yogurt. Maybe to you, a couple hundred extra cups of yogurt a year, but to the average consumer, it's not going to sell. And we talked about performance metrics, and one of the things that was surprising to me when I switched over from production to facilities and utilities was that it felt to me like facilities and utilities really has a blank check in their equipment. If something breaks, here's $10,000, $20,000, $50,000, get that up and running as soon as possible. But if you're working on energy, we all know that before that piece of equipment breaks catastrophically, it's wasting energy. There are some indicators that it's going to fail. And if you're tracking energy, if you're reducing energy, if you're optimizing your equipment, you're going to save money and you're going to save energy indirectly. So I talked about all those things, and I've been working on this for a year, and I've gotten some pretty good reception from people about it. But not as much as I want. I want a lot. I do. And it was getting very frustrating to me, so I decided, I really need to change my mindset. I thought that going after these other factors that would indirectly contribute to energy would get the job done, but it wasn't. So in order not to be frustrated on a daily basis, I decided, I'm going to have to rethink what I'm doing here. I'm going to have to change my mindset. I had changed my mindset from a here's how I can help you mindset. Here's what you can do to save energy, giving them this portfolio, this package of my solutions, which people weren't buying. I'm basically giving my customers, my plants, my maintenance managers, my plant technical managers, this box of solutions and saying, this is what we're going to do to save energy. And they weren't buying it. I'm a saleswoman. And I started having a different dialogue with my plants. And that dialogue was to ask the question, what do you need the most in terms of facilities and utilities? Not here's what I'm going to do to help you. It's what do you need? It's a very different question. And they told me different things. And one of the biggest things was capital. They don't have capital. And you would think that with all those projects, I showed you this bar chart where if you spend a very small amount of money, $300,000 worth of some parts and some labor, you get back $2 million. That's a big deal. I mean, we should be knocking that out of the park, right? But the reality is once you start having these conversations with the plants and you realize that it's not really just about capital, it's about some of the plants are small and they just don't get the capital. Some of the plants have a product that whose consumer relies on innovation, different flavors, different packaging sizes every year. So their capital, a very limited capital, is tied up in production equipment. There are a lot of factors that go into how they get capital, and they just certainly don't get it. And this is something that, even as a part of General Mills, I have a lot of different types of products, a lot of different types of plants that I just wasn't really in tune with, even though I worked for the company for 12 years. And that's certainly not something that you will necessarily have line of sight of with your consumers either, unless you ask, and sometimes they may not be able to tell you what their constraints are. The other thing, HVAC and refrigeration. It's big for General Mills. We have to refrigerate a lot of our products. Some of our production areas require certain temperatures, and we have units that are failing. And that's where we need to invest some of our money. So that goes back to that capital piece. The morale is low in these departments. It's getting hotter in certain areas, staying hotter for longer, more humid. Some of the heat, it impacts dough. Dough has to proof at a certain temperature. You can actually throw away hundreds of thousands of dollars if certain areas aren't at the right temperature and humidity level. We have this R22 phase out that they have to contend with. We have a corporate mandated ammonia refrigeration requirement coming up. And just because corporate mandated it does not mean we're giving our plants money to do it. They have to figure it out with the capital that they're going to get. So they have to come up with a plan to deal with ammonia, which is great for the environment, but for the plant and having to deal with that toxic refrigerant now, that's going to take a lot of capital to make sure the community is protected. And then resources. They just do not have the resources. When I go back to leaks, they just do not have the resources to fix leaks. They have very limited mechanics. And when production goes down, those mechanics are working on production equipment. Production equipment has to run, period. We cannot exist as a business if our production equipment goes down. As much as I don't like it, we can't exist with compressed air leaks. We can exist, and we do exist, with 50, 75% leak rates. I do not like it, but that's the reality. So one of the things that I decided to do to get after those leaks is, and address the issue that plants just do not have the resources to fix leaks, is to just outsource it. So when I was an energy engineer, I was actually an energy engineer at the plant in Murfreesboro. I did just that. I came up with a process, hired a general contractor. They came in, I gave them a do not exceed purchase order. They came in, they fixed leaks, they kept track of their labor hours, they used parts from our storeroom. And then I checked the leak repair progress by looking at the flow meter data. So I was able to check that as pretty much as I want. We had a downtime period in a department that allowed me to get in there and fix it. And what I saw was that probably 90% of those leaks were air prep products, quick disconnects, push and fittings, things that are like really easy to fix, things that you could hear. They didn't even really need to use a lot of ultrasonic leak detection equipment. You could hear these leaks. And we spent about $5,000, and then we ran out of parts. The repair process stopped. But at the end of that process, we did manage to save 350, 400 CFM, about $22,000, just by a little bit of work. And they weren't working consistently through those 2 weeks. They were only in there for a couple hours each day through those weeks. So that was pretty substantial for us. But again, the process stopped. And then there was a problem with that process, which was, at the end, the plant had no accountability at all anymore to fix leaks. They felt that from that point on, it was some job. And my intent was just to get the leaks to a certain point and then allow them to take over. But at that point, they had checked the box. They were no longer responsible for it. So I came up with some solutions to address everything that went wrong with that process. So I wanted to try and do this again, and ran out of parts. I figured, we'll address that by getting a vendor, bring a vendor or manufacturer somebody of these parts that we know we're going to use, come in and fix leaks, instead of using a mechanical contractor who really doesn't know what they're doing anyway, doesn't know the parts they're replacing, they're just replacing part number per part number. The plant accountability piece, I have changed mindset. That's not changed the plant's mindset, that's changed my mindset. Because I was really letting that get to not fixing leaks, just bringing somebody in and sourcing it. Really need to get after that $6.2 million. So I needed to change my mindset around that. And then I decided the sustainability piece, just to really partner with somebody permanently. Just bring them in and build them into that process. So anytime the maintenance manager has some downtime, they know it's coming up, call up this partner that we've worked with. Hey, we got some downtime, bring your parts, come in, bring some folks, fix our leaks, we'll check our flow meter when we're down, we'll see what you did for us. So I set out to find this vendor, and I got on the phone, and I called somebody and said, hey, I need you to come in the plant, fix my leaks, quick disconnects, push and fittings, bring some guys, air prep products, bring some guys. And the response was, I can help you. I'm gonna come in, I'm gonna bring my ultrasonic leak detection equipment, we're gonna do a survey, we're gonna tag the leaks, find out where they're occurring. And I said, no, that's not what I need. I need you to bring some parts, bring some people, come to the plant as you hear them, fix the leaks. He said, I'll get back to you. So I called somebody else for a different plant. I said the same thing. I want you to come in the plant, bring the parts, bring the people, fix the leaks. And he said, yeah, I can help you with that. I'm gonna come in, I'm gonna bring my ultrasonic leak detection equipment, we're gonna go through, we're gonna tag, I'm going to show you where your leaks are at and you can fix them. I was like, no, that's not what I need. I need you to bring your parts and your people and fix them on the spot. That's what I need. It's like, I'll get back to you. So I called another person. Same thing. It happened over and over again. And I'm not telling you this story for you all to call me saying you're going to fix my problem. That's not the point of this story. I'm telling you this story is because I don't want you to make my mistake. My mistake not listening to my customer, not listening to the need, which was what I was doing. You have to listen to your customer. You have to supply what they need. And you have to be empathetic, because sometimes they're not going to be able to tell you why they're being so resistant to something that you think is a good idea, something that they should be doing. Sometimes they'll tell you, sometimes they won't be able to tell you. You need to be flexible and resourceful enough to provide what they're asking for. We have a lot of people in this room, a lot of contacts, should be able to solve any problem. You should be confident enough that regardless of what they're asking for, just say, yeah, I can do it. Go figure it out. I'll figure it out. Come back to your customer. I know you all have the ability to figure it out. And don't rely on those go-to solutions that you already have and enforce those on a consumer. That goes back to what I just said. Be confident that you can come up with something different. Probably been doing this compressed air thing. Some of you have been doing it for decades. And it's not too late for you to reinvent or do something differently that you've been wanting to try that you just haven't considered because your customer hasn't told you or expressed their needs explicitly. So again, in this room, there are so many people. There are manufacturers of pretty much everything that you can put in a compressed air system. There are auditors. There are people who can test for air quality. And if you can do compressed air, you can really do anything, to be honest. Compressed air, if you can do compressed air, you can do steam. Your plant that you call on may need a steam solution. They may need a chilled water solution, HVAC solution. And if you can do compressed air, you can help them with that. Or you know somebody who can help them with that, so do that. So we really have a chance to be heroes to ourselves, right? Because we have we already have the skill set. We have the skill set to help our customers, to really help them, not present them with our list of solutions. And if you're empathetic and you expand that, you should be empathetic with anybody you come in contact with. It's a very different way of just participating in society. And we have the opportunity to be heroes to the world. Very shortly after I became an energy engineer, I attended the World Energy Congress that the Association of Energy Engineers puts on, and I was accepting an award for our plant who did a project that I actually had nothing to do with. I was just there, so I accepted it for them. And I was very excited to be there, and I was having a conversation with a woman and with a group, and she mentioned that she doesn't believe in climate change. And that was kind of surprised me, because I thought that one of the reasons why I got into energy was because I wanted to have an impact on the world, and I think that we're the people that's going to do that. And she said, you know what, I don't really think that climate change is a thing. And I asked her, I was like, well, why are you doing this? I wasn't really thinking. It just kind of came out. And I said, why are you doing this then? And she's like, for the money. And I told her, I was like, that's a terrible reason to do something. We have a chance, we have the opportunity to really make an impact, right, in this room. Thank you.